Hello, third graders. Let's get started with our targets for the second day of geometry. We are going to do some more vocab. Heads up, it's going to be a lot of vocab in geometry, so you guys need to be responsible and keep track of these words. Maybe it would be a smart idea for you to find ways that you can practice them, maybe even outside of school, okay? Be responsible. So this first target says, I can explain the meaning of a line, line segment, parallel, and perpendicular with examples. The second one says, I can identify opposite and adjacent sides of quadrilaterals. You will know you are successful when you can identify and find examples of these new vocabulary words. Third graders, when you think of parallel lines, they are lines that look like these ones on the left over here. This is what we're looking at, okay? So parallel is what we're looking for. I'm noticing on the right it says these line segments are not parallel. Not. So what makes them different? Think to yourselves. How are they not? Well, I noticed that these two touch right there, so maybe they can't be intersecting, but these ones don't touch up here and up here, so
And Miss Anderson, does intersecting mean that they will eventually, or that they are crossing each other?
Oh, so you're saying that maybe since these are lines, they continue on forever. If I continue to draw them, they will intersect each other, so maybe that's it. Third graders, the meaning of parallel lines are two lines that will never intersect. Okay? Never. Not sometimes, never. Okay? Notice that those lines on the right are lines that will eventually intersect. So that is why they cannot be parallel. When I think of the word parallel, it is spelled just like it is over there, P-A-R-A-L-L-E-L. Notice that there are two lines in the word parallel that will never intersect. Two L's. Okay? Those L's are never going to intersect, therefore parallel lines can never intersect. That can be a tool to help you remember what parallel means.
So now, friends, we're moving on to perpendicular lines. So it says the lines or line segments in these pairs are perpendicular. I'm looking at that word perpendicular, and I'm thinking about what we just talked about with parallel lines. I'm noticing that these lines would not be considered parallel because it looks like they are crossing, whether they're a line segment like here, because they do not have arrows, so I know that they are not going on forever, or if they're lines. When two lines or two line segments are crossing or are intersecting, that is called perpendicular. When they are crossing like this, they need to be perfect, they need to be making kind of like a T with their line. So it's going to be a vertical line like this, and then a horizontal line. Horizontal makes me think of horizon, so going sideways, how it makes a perfect T. So friends, you can think about perpendicular when it's making a T. Now I'm noticing over here on the right, it's saying that the lines or line segments in these pairs are not perpendicular. So I'm looking at how the ones on the left are considered perpendicular and the ones on the right are not considered perpendicular. Wondering what's different about them. Stop and think and try to see, what do you notice about the difference between the perpendicular lines and the pairs of lines and line segments that are not perpendicular? Alright, so friends, did you notice that the ones on the right that are not perpendicular do not make a perfect T, or do not cross where they are going directly vertical and horizontal? If the lines are making more of an X, or are not crossing where they're making a T, they are not considered perpendicular. So friends, when it says down here for number 3, it says, what do you think it means for two lines to be perpendicular? I think what I would say is that these two lines, I'm just rereading the question, friends. It's always a good idea to go back and reread. What do you think it means for two lines to be perpendicular? It means two lines that are vertical. They have to make a T.
They have to make a T, but they don't always have to be vertical and horizontal because these lines right here aren't vertical and horizontal.
Good cut. Yep.
So they can be turned. They always have to make a right angle every single time. A corner that's a right angle.
So they have to have a corner. Yep.
So that are forming a perfect cross or a 90-degree angle.
So making a perfect cross or 90-degree,
angle.
Excuse me, third graders. Or 90-degree angle. Thank you, Miss Anderson. That was a good clarifying point.
All right, let's keep moving. So, opposite and adjacent sides, this is what we're going to finish off with today. So, hold with us. It says, look at these quadrilaterals. In all of the quadrilaterals, which means four-sided figures, the sides labeled A and B are adjacent. The sides labeled B and C are also adjacent to each other. So A and B and C. Well, I'm noticing that here A touches B, A touches B, A touches B. And then I'm noticing that B touches C, B and C, B and C, B and C. So I'm noticing that adjacent means two sides that are touching each other or next to each other. That means that they share an end point, okay? They meet at an end point, always. So A is adjacent to B. A is not adjacent to C because A is across from C. It cannot touch C, okay? So let's look at what opposite might mean. So A and C are opposite. That means that they will never touch each other. They are on opposite sides of the figure. So here we can see that A is across from C, A is across from C. Notice that, okay? So opposite means across the figure, adjacent means they're touching. Third graders, we hope that you have a great rest of your day. Apply what you have learned. Remember, you're supposed to be looking for real-life examples. If you need to go back and watch, please do that. Have a great rest of your day.